Hello, I'm Richard Patterson and I'd like to welcome you to another video presented by IPC Irwin. And in this video we're going to look at parallel circuits measuring current at various points, and we'll be using our IPC Irwin power base here for a 12-volt supply, 2 lamps and an ammeter. So I'll just quickly draw the circuit for you that you want to share with your students. We're going to start off here with the power supply, and we're going to come down and go through one lamp connected in parallel and a second lamp connected in parallel also. We're going to join up those lines there. So that's the circuit you'll see me make, and I'll try and make the circuit on our bench look as close as possible to that by trying to make sure that the angles are roughly at right angles there. We won't get it spot on, but students do appreciate the circuit that they build in physically looking a bit like the circuit diagram. And then we're going to look at some points on the circuit which I'll give letters to: A, B, C, D and E. And we're going to use an ammeter, make a break in the circuit there and connect the ammeter in series there to record the current. It's a bit difficult for some students to manage this because they'll have to remove the ammeter, restore the break, and then do that several more times around there. But it's a good exercise for them. And each time they take a measurement, we want to record that in a table. I want to head that up current and show it's been measured in amperes. And if we write down the points there, we'll get a series of current readings, and we're going to look at those and see if we can spot anything about the current. And we're looking to see if Kirchhoff's law does apply. In other words, the current coming into the circuit splits up, goes through the lamps, and then reunites here. We're hoping to see that the current here, A, is the same as E. And if these lamps are balanced, the current coming through each one at D and C should be the same also. So let's connect the circuit up. So we're going to use these incandescent lamps. These have bayonet connections and they tend to run a little hot, so just be mindful not to touch them. They've got 2 connections there, and we're trying to build a parallel circuit there. Now these lamps run at 12 volts and have a power of 24 watts. So I'm sure you know that that means each one will take around 2 amps. If they're in parallel, that means that both lamps together will draw around 4 amps from the power supply. Now the power supply is rated at 5 amps, so that should be no problem. Remember, these Irwin power supplies do have a reset, so if your students do accidentally short out the connection, this thermal cutout will cut off the supply. But that's not going to happen here, we hope. So I'll now slowly build the circuit, trying to make sure it resembles the diagram I showed you before. So the first thing to do is to connect one lamp across the power supply. So I'll twist that round there, so we get it looking at, hopefully, like the diagram. Okay. We're then going to have to connect this lamp in parallel, so I'll just need 2 more leads, which will go there. I'm keeping this side of the circuit using red leads. My students often like that. This is the positive side of the circuit. But I've got a blue wire here, just to show you that's a separate wire there. Okay, so if we switch on, should be fine. There's no short circuits. They're in parallel. They'll draw less than 5 amps, and they're both glowing equally brightly. So now comes the slightly tricky part for our students to start measuring the current. We've talked in other episodes about choosing the right IPC Irwin meter. This one has got a maximum of 2 amps, so that's going to be too small for this practical. This would go into overload. So we'll go up to the 10 amp meter there, and you'll see it comes with a lead already connected. Now, this is a little bit of a an aid for students, because they don't need to connect two leads to this. They just need to make a break and connect one to the meter. So the first thing I'm going to do is look at this side of the circuit here. I'm going to disconnect it. I'm going to put it into one side of the meter there, put it there, switch on the meter, and we can see that roughly 3.4 amps are coming out there. Let's switch off. Let's restore the circuit. And try it on the other side. And again, we've got the same current returning to the positive connection there. So what the current that's coming out here is the same as the current going in there. Now let's try and remove that and check the two lamps. Now, as they're equally balanced, we should see roughly the same current in both sides. So let's break the circuit there. Let's place the ammeter across the gap. Switch on. And we've got roughly 1.8 amps there, which is half what we saw before. Switch off. Restore the break. And let's try this lamp here. So I'm going to disconnect the lamp there, place the ammeter in the gap, using my flying lead, put that in there, switch on, and again, 1.7 amps, roughly the same. So we can see the current is splitting at this point. One current is going through that lamp, an equal current is going through that lamp, and it's joining up on that side and going back there. So ask your students to put that in the table, and then maybe when they write it up, comment on Kirchhoff's law that charge is conserved. Thank you for watching the video. Again, here's our QR code. If you want to check up on any safety instructions and operating instructions, we've got the IPC website there for you to go to. There's a full set of practicals that the IOP Spark site has for you with teaching notes. And for using low voltage power supplies in the lab, we've put in the link to the CLIAPS health and safety website for you to look at as well.